Now we calculate for WKN. This is actually equal to exponent with this function, and we substitute n equal to 8 for split radix 8. So we have 2 pi over 8, and we simplify it into pi over 4k. So based on Euler's identity, from this function, we have cos omega k minus j sine omega k. So we calculate for k equal to 0 until k equal to 7. So based on this Euler's identity calculation, for k equal to 0, we have these values, real numbers of 1, and we convert into polar forms. We have this magnitude and this phase. So again, we repeat the same procedure for k equal to 1 based on the Euler's identity, cos omega k minus j sine omega k. So for this function, based on all these values, we have all 8 position for WK. So the first one is 1 at this location. For k equal to 0, the magnitude is 1, the phase is 0. The next one is for k equal to 1, the magnitude is 1, the phase is negative pi over 4, which is negative 45 degree. So for k equal to 0, the magnitude is 1, or negative j. This is negative j. The magnitude is 1, the phase is negative 90. The next one is k equal to 3. The magnitude is 1, the phase is negative 135, 3 pi over 4, negative 135 here. And for k equal to 4, the value is negative 1 here. The magnitude is 1, the phase is negative 90 degree. So negative 90 degree from here. So we proceed with k equal to 5. We have magnitude 1, and the phase is positive 135. So positive 135 from here. And for k equal to 6, we have positive j at this point. The magnitude is 1. The phase is positive 90 from here, positive 90. And the last one is for k equal to 7. We have magnitude 1, and the phase is positive 45. Positive 45 from here. So for this function, it's actually, when we use this exponential function, it is actually equal to cos omega k minus j sine omega k. Let's say we calculate for k equal to 1. So we have the exponential of negative j pi over 4 for k equal to 1. And then we calculate the cos 45 degree and also negative j sine 45 degree. We have this function. Okay, this function, we rearrange this function into this one in terms of 2 with the power of half divided by 2 with the power of 1. This is actually with the power of 1. And then we rearrange in terms of multiplication. We have this one. And from this one, we combine the power of half and negative 1. We have negative half. And then we rearrange these equations so that we have 1 over sec 2. This 1 over sec 2 is actually equal to this one, 2 with the power of half, negative half. So we substitute back into this one. So we have this one for cos 45 minus j sine 45, which is equal to 1 over sec 2, this function. And then we rearrange this one. We have 1 divided by sec 2 multiplied with 1 minus j. And this is actually equal to, when we convert into polar form, we have this magnitude 1 and negative 45 degrees, same as this answer. Okay, this is to explain this function. And you can repeat for k equal to 3, k equal to 5, and also k equal to 7. You will have the similar answer based on this method, based using the Euler's identity, cos omega k minus j sine omega k. So the next one, we rearrange this equation based on the value of WKN. So we determine the value of xk from 0 until 3 Okay, so this is from the even function. Okay, let's say for x1, this is from the even function g1 plus, okay, this is w1 as discussed in the previous slide, and this is multiplied with odd function h1. And we repeat for x4 until x7, so total we have 8 equation for x1 until x7. And this is for the 8-point FFT based on xn, x from n equal to 0 until 7, to determine the signal for xk for fast Fourier transform for k equal to 0 until k equal to 7.